All right, welcome to lesson 3. Here we're going to be doing something very similar to what we did in the last unit where we created new functions using some existing expressions and some existing functions that we had, most notably profit functions using revenue and cost. So here we're going to implement some kind of more complex situations and add on to our knowledge. So let's go ahead and get started. So to help us kind of understand a way in which we can utilize polynomial functions to model real-life situations, take a look at this particular situation. So Eric is remodeling the storage unit in his backyard. The storage unit is 12 feet by 8 feet by 10 feet. And so there's a couple of things that you want to go through and calculate. So copy each of these down and go ahead and answer them on your own. And even if you're afraid that maybe you're on the wrong track, focus on making sense. So if it makes sense in real life, then it should make sense mathematically, and try and have your math represent the common sense that you are thinking about in your head. And then once you've gone through, go ahead and press play and we'll talk briefly about it. All right, so to find the volume of the storage unit, multiply the length by the width by the height, and that will tell you the number of cubic feet. Remember, cubic because it's in 3 dimensions. So this is the number of cubes, if each cube had a side length of 1, that you could fit, 960 of those cubes, if that makes sense. And so now I want to increase the length and the width and the height by the same amount. Well, what do you want to call this same amount that you don't know? Well, it has to be the same, so you want to use the same variable. And let's just use our favorite variable, x. So now we want to write new expressions for each dimension. So the length was 12, but now we're adding this amount, x, so it's 12 plus x. Similarly, the width was 8, but now it's 8 plus x. And the height was 10, but now it's 10 plus x. And what you'll notice now is that when we multiply the length by the width by the height, we get a slightly different situation. So to write this equation, it will be an equation for the volume, and the volume will be equal to the length, which is 12 plus x, times the width, which is 8 plus x, times the height, which is 10 plus x. Okay, now notice that these are 3 terms, each of which has an x involved. So if you were to multiply this out, you can think to yourself, well, I would get an x cubed term. All right, and you could actually multiply this out, and you get an x cubed. And I encourage you to go ahead and do this. First FOIL these out, and then distribute. Now, if Eric is going to add a small compartment to the outside of the storage unit, it has a volume of 12 cubic feet. We want to update our volume function so that it includes the volume of the compartment. Well, this here gives us the volume of the storage unit. And we know that the volume of the compartment is 12, so what we want to do is add 12 to this. So our new function is going to be the volume is equal to 12 plus x times 8 plus x times 10 plus x plus that extra 12. All right. So now the question says, if Eric increases each dimension by 2 feet, what will the volume of the storage unit and the compartment combined be? Well, what is this 2 feet? This is the value of x, right? The amount that you're adding on. So you can plug in this value of 2 into your function, and v of 2 will be given by 12 plus 2 times 8 plus 2 times 10 plus 2 plus 12. And this will be equal to 1,692 cubic feet. So there are 2 things that we want to take away from this situation. The first is that we can construct expressions with a variable involved and use those expressions and formulas that we know, the volume formula in this case, to write a new type of formula that will give us a volume for our specific situation. We can also take these formulas that we've constructed and we can add in new pieces. For example, I added in this 12 to account for the extra compartment. And then I can analyze the situation by plugging in certain values for my variable and finding the corresponding volume in this case. So this is the big key point that we want to take away. So these are the key points. First, we can build functions by combining expressions and formulas in strategic ways. And we can use these functions to better understand a situation. In building a function, a trick that I always use, and this isn't really a trick so much as it is common sense, is to write out in words what I want my function to do. So if you remember, an example of this is that when I was writing a profit function, I could write out that profit is revenue minus cost. Similarly, if I were doing volume, I could write volume is equal to length times width times height. So let's add to our list of real-world relationships. We have profit is revenue minus cost. And if these were two independent functions of revenue and cost, I could combine them by taking the revenue function and subtracting the cost function to get the profit function. Another one that we just talked about is volume, which is length times width times height. And so similarly, if I have a function or an expression that represents the length, and one that represents the width, and one that represents the height, I can combine them by multiplying them to get the volume. So let's continue to build on these situations and apply them to some different situations where we can combine functions that make sense in order to get a new function that will tell us a little more about a situation. Okay, so here's the problem that I want you to try, this is, in my opinion, even easier than the first problem that you did. So you should have no problem tackling this one, even though it's a slightly different situation. So go ahead, read through it, copy it down, answer it as best you can. You should be able to get complete solutions for A, B, and C, and then we'll compare and work on some more tomorrow.